So if so u squared equals x, so that's a u squared there. Square root x, well, let's square root both sides. We get square root x is equal to u. Okay. So now we want to think about this dx business. So what could we take to help out us with getting it, substituting the dx? Because we've got the bottom and two values here. Oh look, we've got the police next door. Okay, well, anyway, carry on. So how can we get rid of this? Any ideas?
Substitution.
Yeah, okay. So dx du equals 2u. Is that okay? Now, I have got one more step to do to get rid of the dx. What would I do, Talitha?
Multiply by du on both sides.
Yeah. And so we've got that scenario there, yeah? Okay, we're now ready to sub in. Oh, wait, we're not. Ishan, what do we need to do here? Something I've forgotten.
Find the new ranges.
Thank you. Okay, so a new limit. So x equals 2, therefore u equals square root 2. X equals 3, therefore u equals square root 3. Okay. Now, at this point, we're ready to put in our substitution. So we've got our new limits. The equation is 1 over u squared minus u, and then times 2u du. So let's just reflect and check that we're okay with that. This we got from this we got from this, and this bit here we used that. All good? Okay, so we could simplify this down further, couldn't we, by putting this on top, because we're multiplying, so this 2u is simply going to be on the top of this equation here. So, and we could, perhaps we could factorize the bottom there, couldn't we? So the bottom would be u into u minus 1. U into u minus 1. And then we could cancel out the top and bottom u's. So we're left with integral between square root 2 and square root 3 of 2 over u minus 1 du. Now we're ready? Or maybe we could do one more thing. Another way of writing this is two into u minus 1 to the power of minus 1 du. And at this point, in the really back in the deep recesses of your brain from earlier in the year, you should be thinking, oh, this to the minus 1, this is familiar to me, and I'm integrating this. Griffin?
Is it 2l in u minus 1?
Remember that? We don't need a plus c because it's definite integral, and then we've got this. Okay. Chuck that into your calculator, and we'll give this answer to 3 significant figures. So I think it is 1.14 to 3 significant figures. Alright, so number 5, what have we got? Do you want to tell us what's in here, Asian? What have we got?
Use a substitution u equals 2x plus 1. Find the area bounded by the graph of y equals x all over square root 2x plus 1. The x-axis and the line x equals 2.
So if we were to look at the graph here, maybe I'll just sketch this. It starts here, and it goes here, and this is 2 here, right? And they want us to find this area here, and this this function, what's the name of this function?
Y equals x all over square root 2x plus 1. Square root 2x plus 1.
Okay. So, do we know our limits? This is obviously, if we're finding an area, we're using definite integration. So our limits are going to be, Talitha,
2 and 0.
like that. And then x over square root 2x plus 1 dx. So far so good. Okay, well, let's have a look at what we need to replace here. We've got to somehow get rid of this, which should be pretty easy, right? This whole thing is this to the power of, close?
Minus 1 half.
Minus 1/2, because it's at the bottom of the fraction here. Our next step might be to figure out our new limits. So, do you want to tell me the new limits, Rebecca?
0. Oh, 1, sorry.
Yep, x equals 0, u becomes 1. X equals, what's it, 2, u becomes
5.
Okay, those are our new limits. What might we want to do next, do you think, Griffin?
You could do du dx.
Of this, yeah, okay, let's do that, shall we? Du dx is equal to 2. We want to get dx by itself. So, next step, what do you reckon, Ishan?
You multiply it by dx.
Yep, so we're going to have du dx equals 2 dx. Now you'll see that this cancels out. We've got a du, which is what we need to replace the dx with. What am I going to do with this 2?
Divide.
Yeah, get it over to the other side. So we have du, 1/2 du equals dx. Alright, so we got rid of, so far we've dealt with this, and we've dealt with this. We've got to figure out this one here. Now, could we rearrange this? Yep. Okay, oh, well, let's do that up here perhaps. U equals 2x plus 1, u minus 1 equals 2x, and therefore x equals u minus 1 all over 2. Okay, so we've now, let's just refresh what we've our memories here. So we've got this from this, essentially, and we've got this also from that, but we've dealt with that over here, and we've got this bit here by rearranging that bit there. Okay, what's our next thing going to be that we do here, do you think, Ishan? Put it all together, okay, so new limits are 1 and 5, right? Yep. U to the power of minus 1/2, that's that bit, times u minus 1 all over 2, times 1/2 du. Looks pretty horrific, doesn't it, really? I might just move that down a bit so it looks better. Okay, next line. Our denominator is going to be 4. Then we're going to, in it, we're going to have 2 terms, right? We're going to have u to the minus 1/2 times u, add the indices when we're multiplying, so it'll be u to the power of half. And then u to the power of minus 1/2 times minus 1, which is minus u to the minus 1/2 du. And for the purposes of what we're doing, it is probably better to write it like this. Maybe I'll just move this over a bit. Now, we're going to get our square brackets. Let's look at this first term. So, we're raising the power of u, so it's going to become u to the power of 3/2. This 1/4 becomes, we're going to times it by 2/3, so it'll be 2/12, which is 1/6. Everyone okay with that bit? Yeah. Subtract, because this power is going to be 1/2, isn't it? U to the power of 1/2, we've gone up 1. So to keep that minus, we've got to just leave it as a minus, because a positive times minus is minus. Okay, what does this become? Half. 1/2 times a half gives us a quarter. We don't need the plus c because it's definite. And then 1 and 5.
How would it be a minus minus?
Sorry? Here?
Yeah, shouldn't it be a minus minus?
Why?
Oh, you're telling me by.
Because I raise the power, how do I get... So this is, we've integrated, so when we go back, half times minus half gives us the minus 1/4.
Oh.
Yep. Okay, cool. So now we want to chuck in our values. You could probably just chuck this into your calculator now. Should be getting 1.08 to 3 significant figures.